To determine the average time a customer will have to wait for a response, we must determine the total time the email spends in queue, as well as the time it takes the lawyer to write his response. We'll ultimately want to use the waiting time formula, so let's begin with that. It's equal to the activity time times the utilization over 1 minus the utilization times the coefficient of variation of the inter-arrival time squared plus the coefficient of variation of the activity time squared all over 2. We'll have to now solve for several of the inputs into this equation. Let's start with the activity time, P, which is given to us as 5 minutes. The CV of P is equal to the standard deviation over the mean. Our standard deviation has been given to us as 4 minutes over a mean of 5 minutes. That's equal to 0.8. A, or our inter-arrival time, is an input into utilization. We know that there are 60 minutes in an hour and an email is arriving, or 10 emails are arriving per hour. So we can solve that a new email arrives every 6 minutes. CVA has been given to us as 1. Finally, we'll solve for utilization, which is equal to P over A, or 5 over 6. Now we can plug all these into the equation above. 5 times the utilization of 5/6 over 1 minus the utilization to get 1/6 times 1 squared plus 0.8 squared all over 2. You solve this out and you get a waiting time of 20.5 minutes. The customer also must wait for the 5 minutes that the lawyer is writing his response, so it's actually 25.5 minutes before the response gets to his inbox. Let's move to part B. We know that there are 10 hours in a working day and that 10 emails arrive every hour. Multiplying this out, we get 100 emails per day. Part C asks us to identify the amount of idle time the lawyer could spend pursuing his leads. We know that the utilization is 5/6, so the idle time is equal to 1 minus the utilization, or 1/6. Multiply that times the 10 hours in a day, and we get that the lawyer has 1.66 hours of idle time per day, or 1 hour and 40 minutes that he could spend generating leads. Part D is a bit of a trick question, because the standard deviation, the one input that's changing, does not affect utilization, only the coefficient of variation. Therefore, there would be no change in idle time, and he could not spend any more time on his leads. For part E, we'll use the same formula as above, but we'll need to recompute the coefficient of variation for the activity time based on the new standard deviation of 0.5. The mean stays the same, so our new CVP is 0.1. Now let's plug all the other inputs into the equation. An activity time of 5 times a utilization of 5/6 over 1/6 times 1 squared plus the new CVP of 0.1 squared all over 2. This yields a response of 12.63 minutes of waiting time. Just like in the previous part, the lawyer will take 5 minutes to actually write his response, so it'll be 17.63 minutes before the customer hears back.